So here, as we start to talk about absolute value, now not just absolute value, but equations and inequalities. We've talked about both of these so far, but we're going to put in a little twist with the absolute value here. So reminder, absolute value is a distance from zero on a number line. It'll always be positive or zero. The thing I always like to make people think about is you're driving a car, okay? Whether you paid attention to this or not, you probably know this is going to be true. When you drive a car, your odometer, your mileage goes up. It doesn't mean then that if you went somewhere and then you drove backwards, or you drove in reverse all the way back, the mileage all reverses. That's not how it works. You're still moving ahead. It's a distance. So, whether you're talking about a distance from 0 to 4 being 4, or 0 to negative 4, the distance, how far you've traveled, is still positive. So when it's an absolute value, if it's positive, it stays positive. If it's negative and it comes out of there, it becomes positive as well. 4. But what's inside the absolute value can be positive or negative. The absolute value of x is 5. It can be 5, makes sense. The absolute value of negative 5 is also 5, okay? So, the numbers inside can be either. Once they come out, that's the part where they're going to be positive. And so, when we go to do equations with these, you're going to notice something right away. When we have an absolute value equation, just like we did here, there's two solutions. You can come from the left, you can come from the right. So, when you see an equation like 2x minus 5, the absolute value of that equals 9, you're going to have two equations. The first one, you basically just rewrite what you see and you leave everything alone. You just drop the absolute value bars. But for the second one, you leave what's inside the absolute value alone, but you're changing the sign of the answer to negative. That's how you're going to get your two distances on each side. Once I have them set up, it's not bad. Now it's just regular two-step algebra 1 equations, which shouldn't be too rough to deal with, hopefully. Just again, caution on little things. Like that you're adding 5, but that's a negative. And getting to your two solutions. Okay. For the most part, these aren't going to have anything that really can hook us in a bad way, except if we go fast and get a little careless. So, to try and avoid that problem as best we can, and we're also going to chat about a special case. Do I want to do that here? Hang on a second. I want to look at one thing. I thought. We'll chat about that when we get to the bottom of this page. Okay. So inequalities, just like before, you're flipping the sign for a negative number. I'll explain that in a little more detail here in a sec. Absolute value of 2x plus 7 is less than 11. On this next quiz, what gets missed most often? People pay no attention to whether it's absolute value or just a regular inequality. There's a difference. A regular inequality, you solve it, you're done. These, we got to have two. First one, copy what you see. Just lose the bars. Second one, hi. Get those. Yes. Yeah, thank you. The second one, left what's inside the absolute value alone. We flipped the sign and we changed to a negative. You've got to do both. If you miss one or the other, when you get to the end and try to graph it, it's going to make no sense. So I get to here, and I go, okay, let's solve this. This part, not an issue. Get that set over here. Again, I want to take my time, but I want to be careful of certain things. Like here, I don't want to be over flippy. Here, I'm dividing both sides by positive 2. Just because you see a negative, I'm not flipping again. Here, dividing by positive 2, that stays. And you might be wondering at this point, bless you, how do we know that this is and? Like, I see and in the middle. Where did that come from? Whenever you see an absolute value is less than, okay? If the absolute value is less than, if the arrow is pointing at it, it's an and statement. In our heads, now we know what the picture should look like. So I'm like, okay, let's see here. Least to greatest on a number line. Okay, we can't flip those. And we know should come together in the middle. So I look, and I'm like, all right, x is less than 2. Less than's a parenthesis. Okay, less than goes left. X is greater than -9. Okay, greater than goes right. Yeah, they're gonna crash in the middle here. Okay, that's good. They're not both going one direction. They're definitely not going out from each other like an or statement. And so once I get here, my interval notation just goes from left to right, same symbols. So just about that whole thing was exactly what we were doing at the end of last week with our and statements. The only difference is you've got to set it up because of the absolute value inequality. And that's it. And so just like we said, less than is and. If we have greater than or equal to, that's going to be an or statement. Now, is it the end of the world if I don't know what word to put in the middle and all I did when I got here was I wrote my two expressions as long as I get the arrows right, the signs? Not really. It's just one more clue to make sure, hey, is this matching up with the graph that I should get? If it does, great. It's one more thing, check. And if not, then it's like, wait, there's a little problem here. So just like we did there, nothing different. Copy the first one. Second one, the arrow flipped, the sign changed. Nothing different. Okay, the process is the same. So I look, and I'm like, okay. Ooh, looking at fractionally, decimally stuff. Yuck. All right. I would understand if you decided here, since you're graphing, if you would ponder going to a decimal here, or a mixed number even, like 3 1/3. I'm just going to stick with this, but totally get that if you went that route. Again, here, just like we had here, what are you doing to get x alone? I'm dividing by +3. Do not flip. Again, at least, we'll say. But I got a picture in my head now. Ors go out. If these don't go out from each other, So if I plug that in my calculator, that's like 3.33. I'm just keeping that in mind. So when I go to graph, and I start looking, I'm like, ooh, I'm feeling good. X is greater than, the arrow eats X when it's greater than, so that's going this way. Bracket because of the or equal to. X is less than or equal to -2. Less than goes left. Looking like it's supposed to. Ors are very inclusive and have really big graphs. And so now for my interval, again, left to right, least to greatest. Least, -infinity,
First stopping point at -2. But there's more. Yes, you need the U to let people know, yes, this is all part of the same graph. We start up again at 10/3, 3.33, 3 1/3, and go off forever to positive infinity, which is always going to be parentheses. It has no definitive endpoint that it works with. I will warn you with these. This is similar to what we talked about last time too. Absolute value, we still got to think about the negatives here if you start with 1. We'll chat about that at the end, but that's going to be our exception to these. All the rest of them will always be normal. I guess we'll air quote normal, like these as we go. So here's what I'm going to do here. We're going to jump down to number 3 because the other ones are pretty straightforward. Thank you. Right. Good there. Just a reminder. And as I always say with these, any examples that we don't do now, I do have completed online. So if you wanted to go back and see them, be like, wait, how's this? And then we go. Okay, so here. Is this going to be an and or an or? Or. So in my head already, I see the graph going both directions. I know what I'm looking for. So just copy it the first time. Don't change a thing, except that the absolute value bars are gone. Yes, greater than or equal to is going to be an or. Yes. It greater than or equal to. Any greater than that you get into is going to be an or. Yeah, the or equal to part isn't going to matter on the and or. It's just whether it's greater than or less than when we're doing those. And then over here, leave what's in the absolute value bar alone. Flip the arrow. Change the sign. Always those same 2 steps on the second part. And now we just solve what we got. But this one I chose because when we get to that last step, that's not solved for yet. That negative is still there, and we know what happens now. Divide both sides by a negative. You've got to flip the inequality arrow. And if I got to do it on one of them, I'm going to have to do it on both. Because again, I know what this should look like. So now we get to see, is it going to do what it's supposed to look like? Let's see. X is less than -1. Less than goes left. Or X is greater than 11. Bingo, looking good. And then again, interval notation, least to greatest, left to right, negative infinity. Stops the first part at -1. Fires back up again at 11. And forever off to the right we go. So let's think about, before I get to this last piece of things. Oh, wait. Nope. It's coming. It's coming. I got to be patient. I was smart enough to put the special cases right in the notes. Okay. So every one of these that we've done so far, let me come back down a little, has had your absolute value isolated. Okay? It's just been the absolute value on the left, nothing else. That will not always be true. Because now, if there's other stuff going on, we're adding something, we're multiplying something, we're doing something like that, you've got to isolate it. You have to get it by itself before you can do the problem, or it won't work. For instance, here, that plus 2 has got to go before I split it. Well, what if I forget? What if I forget and I just split it with the plus 2 there? What's going to happen? One of your answers is going to be right and one of them's going to be wrong. I'll guarantee it. So we'll minus that 2 on out of there. We're going to go into a split here. Copy on the first one. Second one, in an equation, we're just changing the sign. And that's it. And solve what we have left. Okay? So the actual work that you're doing is no different. So all I'm going to do on these last two, I'm not going start to finish on the whole thing. It's just to be there as a reminder to you. Isolate, isolate. Isolate, then start, then split it into your pieces, then look at this and say, hey, that's an and statement because it's less, and so now I'm going to do, okay, copy it, and in the middle to remind me, hey, this is the one where they're going to come together in the middle. Flip the sign, flip the arrow, change the sign. And yes, sir?
And if you have, like, say, a negative 2 outside the absolute value, you have to flip the sign as well, like before you flip the absolute value.
So, like, this one specifically, or are you saying, like, if I had...
So you had negative 2 times the absolute value.
Good question. So let's say this looked like, because I think I know what you're saying here. So it looked like that. Okay. So if I have something like this, you're right. Before I get started, there's a couple of things I'm going to have to keep an eye on. And this is actually going to lead very nicely into the last part of our notes. So here you would be like, okay, I got to isolate this first. Now, I'm going to leave you slightly in limbo here, because this is about to run us into a special case. Because before we had an issue where you're like, well, wait a minute, absolute value is always 0 or positive. That's not 0 or positive. What the heck? If I went through and split this and did all the things that I did, I'm going to run into a problem because it's not going to match. Like before we had ands that were going like this and everything going one way. This is going to cause me the same problem. Anytime this is alone, your absolute value, and you see a negative over here before you split it, special case incoming. So, with that in mind, it's almost like I planted you to do that because it's like, it's perfect going into this. Special cases to wrap. Ooh. So here, this is similar to what we just had here. There's my absolute value. It's alone, though. Greater than or equal to negative 13. So you're like, okay, so what? So let's just say, here comes another post-it note, which is the watch and see, but don't write, because that can cause a problem. So let's say I split this. And it's an or, so I know what I'm getting into. I flipped the arrow, I changed the sign, just like Hardy said to do. So I go through, and I'm feeling good about this, and I'm like, all right. Got that. Minus that. Got it. Okay. In my head, ors go out. So I'm like, all right, here we go. D, -8, 5. And then I start doing, I'm like, wait a minute. That looks like an and. That's not good. But here's the thing. This can happen. It can. But here's why the answer I'm about to show you is what it is. This one is all reals. Everything works. You're like, wait a minute. How the heck is that true? Okay, because remember, ors are inclusive. This, as it comes this way, this is going to go right through here and keep right on going. This is going to bust right through that end point and keep right on going. The only reason with ands we stop is because ands only want what's in common, which is in between the two endpoints. Ors don't. So by knowing on this one that it's an or, that's going to make all the difference in the world. Because now when I do my graphing and it comes together in the middle, I'm like, nope, got to be inclusive. Here's the other thing you're going to know. Okay, here's a question for you. If this part is always positive or 0, okay, is 0 greater than or equal to -13? Yeah. Is any positive number greater than or equal to -13? Yeah. No matter what number I plug in for x, it's going to be greater than or equal to -13. Every time. Every single number will work. That's why I don't have to do all this if I see the negative and I stop and I think about it for a minute. Now, I do all this. Sure, I can still get there. But if you see the negative right away, it's a special case. You do not have to do all the work if you recognize it. So that's going to be an interesting thing for some of you on this. Because here, the same thing is about to happen. This is an and. It's exclusive. Now, this is still always positive or 0. So let's think that through. If this is 0, is 0 less than or equal to -2? Nope. Is any positive number less than or equal to -2? Nope. Nothing is. Nothing's going to work. So this one, you can write a couple of things. You could put no solution. You can put what's called empty set. Okay? Because if I worked this one completely through, Hardy going in super mode on this one, knowing that it's an and. Minus the 2. Minus the 2. Looks like an or. What do those two graphs have in common? Nada. Nothing. 0, zilch. And so that's what ends up happening here. We end up without having a solution of any type. And that's a little yucky. So That's the one thing we've got to watch for when it comes to those. And the final thing, it's actually the easiest thing, hallelujah, there's something easy to this, right? There has to be something. Write an absolute value inequality from a graph. I'm going to apologize that these have dots instead of brackets. I don't know how I let that slide. X minus the center is going to get me the number of spaces from the graph. So here's all we're doing. I can see right away, this is an OR. ORs, I know are going to be greater than. Since I see brackets, I know it's greater than or equal to. So I'm going to find the center of these two. I could add them up and divide by 2. I could be classic. Or I can just kind of space my way in. Okay, there's my center. My center's at 1. X minus 1. And then the number of spaces from the center. How far is it from 1 to 4 or 1 to negative 2? 1, 2, 3. And I'm done. Same if it's an and. I get my absolute value set. It's an and, so I know it's less than. It's parentheses, so it's not a line under. It's not or equal to. Work my way in from the ends. You're like, uh-oh, Hardy, this doesn't come out nice. Nope. What's in the middle of negative 2 and 0? Negative 1. That's my center. Ooh, be careful. X minus the center. X minus negative 1. Ooh. And then from negative 1 to negative 6 or negative 1 to 4 is 5. And I'm off and running. You know the last thing what I'm going to say is, as far as the practice goes, it's the first assignment in your practice packet, your new one. Again, odds and a min because you have answers. Okay? If you need some other ones and you're trying them and you want to see me about those so we can answer them, great. Let me know. I can go back and forth with you there. But at least do those to know, number 1, reinforce the lesson, and number 2, to make sure you know what you're doing. So again, new packet, break it in here on 1 and 2 with some odds. We'll chat a little bit more about some of